two negative charges of negative 3.00 times 10 to the negative 4 coulombs exert a repulsive force of 15 newtons on each other. What distance separates them? So to solve this, we're going to be using Coulomb's law, where the electrostatic force equals Coulomb's constant times charge 1 times charge 2 divided by the distance between the objects squared. Now, if we identify what we're given, we have two charges, so both charges, Q1 and Q2, are both negative 3 times 10 to the negative 4th coulombs. The electrostatic force is given to us as 15 newtons. And then, of course, we also have Coulomb's constant, which is always 9.0 times 10 to the 9th power newtons times meters squared divided by coulombs squared. So if we plug in all of our numbers into the correct spot in our formula, we get our force, 15 newtons, equals Coulomb's constant, 9 times 10 to the 9th power, times the first charge, negative 3 times 10 to the negative 4th power, times the second charge, negative 3 times 10 to the negative 4th power, all divided by distance squared. So if I multiply all my numbers on the top, I get 15 newtons on the left is equal to 810 divided by r squared. And I'm trying to solve for r, so I need to get r out of the denominator, so I multiply by r squared on both sides. And r squared cancels, and then I get 15r squared equals 810. Divide by 15 on both sides, and then I get r squared equals 54. But I'm not solving for r squared, I'm solving for r, so I have to take the square root of both sides. And when I do that, I get r equals 7.35 meters. Now, the other way you could do this is, instead of plugging all the numbers in here and then working through and solving, you could take the original equation and rearrange it to solve for r. And if you do that and you use your algebra correctly, you'll get r equals the square root of Coulomb's constant times charge 1 times charge 2, all divided by the electrostatic force. And if you plug your numbers into this equation, you'll still end up with our same answer of 7.35 meters.